Here's a review of your MT9 final affirmation. Let's start with transformations of a graph, especially a parabola. If you have the form f of x equals a times x minus h, the quantity squared, plus k. Each of those means something. A is going to be a dilation. So if a is greater than 1, your graph is going to get skinnier. If a is less than 1, your graph is going to get wider. If a is negative, that means you're going to flip it over the x-axis. The value of h, notice it's minus h. H is your horizontal translation. So if you have x minus h, we're going to translate it to the right that many units. If you have x plus h, that means x minus a negative h. That's what it really means. So then you're going to translate it horizontally to the left. And then the value of k is a vertical translation. You're going to translate your parabola up or down. Up if k is positive, down if k is negative. So if we take a look at the first question, we have x squared plus 3. Notice k is 3. So we should have gone up 3 and then drawn your parabola. The other one is x plus 2 squared, which remember that's the same thing as x minus a negative 2 squared. So you're going to translate it 2 places to the left. And we don't change anything else. That's what you should have done for that problem. You didn't do this problem. First you have to get rid of the parentheses. So we're going to take y minus 1. We're going to multiply that by y minus 1. You cannot distribute that squared across a plus sign or a minus sign. So we'll double distribute here. Y times y is y squared minus 1y. Distribute the negative 1. So you minus 1y again. A negative times a negative is a positive. So on the left side, that simplifies to y squared minus 2y plus 1. This is very similar to problems we did in the assignments. 2y squared minus 12y plus 22. In order to solve a quadratic equation where you have a squared term and a linear term, you have y to the second and y to the first, it's got to equal to 0. So we're going to make it equal to 0. So I think what we'll do is we'll move everything from the left to the right. So I'm going to minus y squared from both sides. On the left side, the y squareds cancel. That's what we want to happen. On the right side, 2y squared minus y squared is 1y squared. Then we'll add 2y to both sides. And once again, negative 2y plus 2y, that makes 0. That's the reason we did that. And we go negative 12y plus 2y, that'd be negative 10y. And then finally, we'll subtract 1 from both sides. So once again, we get 0 on the left side. And on the right side, 22 minus 1 is 21, equals 0. Now you could solve this by completing the square or by factoring it. Factoring is shorter if you can factor it. So let's try to factor it. So I have 0 equals, I'm going to make 2 parentheses. I know y and y goes here. And then I need two numbers that multiply to positive 21 but add to a negative 10. What two numbers do that? Well, that'd be negative 7 and negative 3, wouldn't it? Because 7 times 3 is 21. Negative 7 plus negative 3 is negative 10. So I'll say y minus 7 and y minus 3. Now we use the zero product property. That is, we know these two multiply to 0. That's the reason we liked it. So we say y minus 7 equals 0, or y minus 3 equals 0. What number minus 7 is 0? Well, that would be 7. Or what number minus 3 would be 0? That would be 3. So your answer is y equals 7 or y equals 3. If we take a look at this problem, not the way you did it. You cannot solve this when you have an x squared just by dividing by 3. That doesn't make any sense. 3x squared divided by 3 is not x, it's x squared. Anyway, so we're going to do the same thing we did on the last one. I want to make one side equal to 0. I think what I'm going to do is I'm going to move both of these to the left side. The reason I want to move to the left side is because I want to keep my x squared positive if I can. It just makes life easier. So we minus 5x from both sides. So I get 3x squared minus 5x. And minus 2 from both sides. So I get 3x squared minus 5x minus 2 equals 0. And now we can solve this by completing the square or by factoring it. I happen to think that factoring is shorter, but you could argue and you complete the square. So we're going to multiply. When you have a number in front, we're going to multiply 3 times negative 2. That's negative 6. I want my middle term to be negative 5, which means I have to multiply two numbers that have a multiply to a negative. So one's positive, one's negative. And have to add to negative 5, so I want the bigger one to be negative. So I'm going to go, oh, negative 6 and positive 1. This isn't any different than what we did in MT8. So instead of writing 5x, I'm going to write negative 6x. So I'm going to go 3x squared minus 6x plus 1x minus 2. Now we factor it, look at two at a time. I look at just the first two terms. What goes in the first two terms? Well, that would be 3x. So then you get 2x. Let's try that again. 3 divided by 3 is not 2. I get x minus 2, because 3 times 2 is 6. I look at my next two terms, and at first you go, nothing goes into both of them. Well, 1 goes into everything, so I'll say plus 1 and x minus 2 equals 0. Notice the x minus 2's are the same, aren't they? So we're going to factor that parentheses out. So I'm going to say x minus 2, which means the second parentheses is going to be what's left over, which is 3x plus 1 equals 0. Now we're going to apply the zero product property. So we're going to say, oh, x minus 2 equals 0, or 3x plus 1 equals 0. So we add 2 to both sides. X equals 2. Over here, we're going to subtract 1 from both sides first. So then we get 3x equals negative 1. To get x by itself, you divide by 3. X equals negative 1/3. So your two answers are x equals 2 or x equals negative 1/3. And that's how we solve a problem like that. Now in this problem, we're going to work backwards. I told you the answers, and I want you to write the quadratic that has that. So we're going to say, oh, this means x equals negative 3, or x equals negative 10. I'm going to make it equal to 0. So what I'm going to do is I'm going to add 3 to both sides. So on the left equation, I get x plus 3 equals 0. I guess I didn't show my plus 10 there. I should have. And then, oh, not plus 10, plus 3. My brain went to the next problem. Then on this one, we're going to add 10 to both sides. Then we're going to get x plus 10 equals 0. Well, since they both equal 0, I'm going to multiply them together. I'm going to say, oh, x plus 3 times x plus 10. You see, we're just working backwards to get that polynomial. Now we'll distribute. We'll double distribute. We're going to take x times each term. So we get x squared plus 10x. Now let's distribute the 3. So we get positive 3x plus 30. Finally, combining your like terms, we get x squared plus 13x plus 30 equals 0. So we're going to find so in function notation, f of x equals x squared plus 13x plus 30. There's your answer. We start from our answers and we work backwards to the question, kind of a Jeopardy question. Okay, this problem. We want to graph the parabola. I want to plot 5 points. The vertex, 2 points on the left and 2 points on the right. Now, I like what you did here, except you didn't graph it. You had to actually graph these points. So you did negative. I'm going to blow this up so you can see a bit better. 2x squared minus 4x minus 3. Copied it down right. Then you do the opposite of b over 2a. So the opposite of b is 4. 2 times 4. Oh, there's your problem. What's a? A is 2. So let's go from there. Okay. So we have the opposite of b over 2a. So it's the opposite of negative 4, which you did correctly, over 2 times 2. So we get 4 over 4, which is 1. That's the x-coordinate of our vertex. So now we're going to make our table. Our x, do they use y? Yeah, we'll make our xy table. I think that's what happened is because you made that small error, it probably didn't work out for you, so you didn't know what to do from there. And I'm going to put 1 smack dab in the middle. And I'll have a couple numbers to the right, so 2 and 3. A couple numbers to the left, like 0 and negative 1. I always like to start with the vertex. So let's do the vertex. So we're going to put 1 in for x. So y equals 2 times 1 squared minus 4 times 1 minus 3. Well, 1 squared is 1, so it's 2 times 1. Copy down the rest of the problem for now. Let's multiply. 2 times 1 is 2. 4 times 1 is 4 minus 3. 2 minus 4 is negative 2. Minus 3 is negative 5. So when x is 1, y is negative 5. That's our vertex. So I'm going to go over 1 on my grid and down 5. There's your first point. Now, let's do another point. Let's do when y is 0. Or not y 0, when x is 0. So y equals 2 times 0 squared minus 4 times 0 minus 3. I like 0 because look what happens. You get 0 minus 0 minus 3, which is negative 3. So when x is 0, y is negative 3. Then let's do negative 1. I'll go y equals 2 times negative 1 squared minus 4 times negative 1 minus 3. Well, negative 1 squared is positive 1. Minus 4 times negative 1 minus 3. So we get 2 times 1, which is 2. A negative times a negative is a positive 4 minus 3. 2 plus 4 is 6, minus 3 is 3. So I'm going to graph -1, and +3. And there's that point. Okay, let's do another one. Let's do when x is 2. So we'll do y equals, that green's kind of hard to see. I'm going to change it to a darker color. We'll go y equals 2 times 2 squared minus 4 times 2 minus 3. Well, 2 squared is 4. 2 times 4 is 8. 4 times 2 is also 8 minus 3. So 8 minus 8 is 0, minus 3 is -3. Look how that matches up. When you're over 2, you're also down 3. And then finally, let's do 3. So I'll go 2 times 3 squared minus 4 times 3 minus 3. Well, 3 squared is 9. Let's do the multiplication next. 2 times 9 is 18. Minus 12 minus 3. 18 minus 12 is 6 minus 3 equals 3. See how it's symmetric? So when I'm over 3, I'm up 3. And for you, on the Alex program, you can just draw your graph. And there you have it. That's how you would do that problem. That required a little bit of work, didn't it? Okay. Want to find all the zeros of the quadratic function? Well, replace y with 0. 0 equals x squared minus 8x plus 12. Can I factor this? Can I find two numbers that multiply to a positive 12 but add to a negative 8? How about -6 and -2? So we get x minus 6 and x minus 2. So that means x minus 6 equals 0 or x minus 2 equals 0. So we add 6 to both sides. X equals 6. We add 2 to both sides. X equals 2. There are your two answers. Your zeros are 6 or 2. I guess when you type it in on Alex, you're going to go x equals 6, 2. That's how you would type your answer in. Okay, let's take a look at this one. I want to solve the quadratic equation this time by completing the square. This, you didn't show any work on this one. This is one I kind of expected you to show some work. To complete the square, you want the x's on the same side. So what we're going to do is we're going to move the 36 to the opposite side. So we're going to minus 36 from both sides. I'm going to rewrite this where I got more space here. So we get x squared plus 14x, leave a space, equals 36. I don't think I left, oh, I did leave enough space there. Then on the side, we take the coefficient of the x term. I'm going to take half that number, and I'm going to square it. Well, half of 14 is 7. You square 7, you get 49. So we're going to add 49 to both sides. This is the part you're going to write in. Now we're going to factor the left side. I wanted it to be a perfect square, so I made it a perfect square by including that 49. So the square root of x, square root is x. We get the plus sign from the middle, or we just look at our work here. And notice the square root of 49 is 7, so x plus 7, the quantity squared. We're going to add 46 and 39. Let me see, 9 plus 16, 9 plus 6 is 15, so we get 85. So now, we're going to say we're going to pick our first one here, and we're going to say x plus 7, the quantities, whoops, didn't mean to do, I was trying to highlight that for you. So x plus 7, the quantity squared, equals 85. That's what you should type in the first one. Now we're going to continue to solve this by completing the square. So now what we're going to do is we're going to take the square root of both sides. So then we get x plus 7 on the left, because the square and square root, they're inverse operations. We get plus or minus the square root of 85, because we get a positive or a negative. Now we're supposed to use our calculator here. So now, to get x by itself, we subtract 7 from both sides. And the exact answer is x equals negative 7 plus or minus the square root of 85. We're going to use our calculator now. So we're going to take negative 7 plus the square root of 85. Oh, that's not it. There we go. So we're going to say negative 7 plus the square root of 85. One of our answers is 2.22. Round it to the nearest hundredth. And let's do negative 7 minus the square root of 85. And we get negative 16.22. And those are the two answers you should have typed in for x. Should have been 2.22, comma, negative 16.22. Okay, so we're going to translate this graph. There's just two steps. H is 4. So we're going to translate it to the right 4. K is 5. I'm going to translate it up 5. So we're going to take my vertex. I'm going to drag that over 4 and up 5. There's my new vertex. And then there's your problem. Okay, on this one, you got everything right except for the vertex of this function. So the vertex is the opposite of b over 2a. That's the axis of symmetry, but it's part of our vertex. X equals negative b over 2a, but want to be specific. So the opposite of b should be the opposite of negative 12 over 2 times negative 3. Well, the opposite of negative 12 is positive 12. 2 times negative 3 is negative 6. 12 divided by negative 6 is negative 2. So the x-coordinate of your vertex is negative 2. Then, to find the y-coordinate, we're going to find f of negative 2. Replace x with negative 2. So you have negative 3 times negative 2 squared minus 12 times negative 2 minus 8. Order of operations, let's do the exponent first. So negative 3 times 4 minus 12 times negative 2 minus 8. Negative 3 times 4 is negative 12. And negative times a negative, negative 12 times negative 2 is positive 24. And we subtract 8. Now we're just going to simplify that. So negative 12 plus 24, well, that's 12. 12 minus 8 is 4. So the vertex of this problem is negative 2, comma 4. Okay, this one. Solve w squared equals 64. This is actually simpler than completing the square. This is a problem you did before completing the square. So w squared equals 64. Well, to get w by itself, we undo the squaring. So we square root both sides. So the square root of w squared is w equals plus or minus, what's the square root of 64? 8. So you should have typed in w equals 8, comma, negative 8. Or negative 8, comma, 8. The order doesn't matter. Okay. You solve this problem by completing the square. which is right. This part is right. That's why I gave you some partial credit. But you didn't follow the directions. I want you to solve this equation by graphing it. So to graph it, we're going to find the vertex and 4 additional points. I think you're actually on the right track here. Let me blow it up to take a look at it. Oh, you didn't show any work to find the vertex. Let's take a look and see if you did it right, because you told me the vertex is -2, -6 kind of looks like. So let's go through this. So x equals the opposite of b over 2a, just like the previous problem we did. So the opposite of 8 over 2 times 1. And I just noticed you did that wrong, because it's -8 over 2, which is -4. So when you make your table, your XY table, your X f of x table, what did they use on this? They used, doesn't matter. I'll go f of x. So I want you to put -4 right in the smack middle of that table. So I'll go a couple numbers to the left, -5, -6, a couple numbers to the right, -3, -2. Now, we will put those in. So we have x squared plus 8x. I'm going to put in -4. So let me write this down. X squared plus 8x. What was the... Wow. X squared plus 8x plus 12. Okay, so now let's put in -4. So I have -4 squared plus 8 times -4 plus 12. -4 squared is 16 plus 8 times -4 plus 2. 16, 8 times -4 is -32 plus 12. 16 minus 32 is -16 plus 12 would give me -4, won't it? So -4, -4 is your vertex. Now let's do -3. So -3 squared. In fact, I'm going to plot that point before I forget. -4, -4. Now, we'll put in -3. So -3 squared plus 8 times -3 plus 12. Well, -3 squared is 9. 8 times -3 is -24 plus 12. Let me see. 9 plus 12 is 21. Minus 24 is -3. So when x is -3, we're going to be at -3. That's kind of weird, isn't it? So when I'm at -3, I'm at -3. I wonder if I'm at -2 if I'll be at -2. Well, let's find out. Now we're going to do -2. So -2 squared plus 8 times -2 plus 12. Well, -2 squared is 4. 8 times -2 is -16 plus 12. 4 plus 12 is 16 minus 16 is 0. That's your solution. When it crosses the x-axis, that's your 0. And notice, you had that correct. When you're at -2, we're at 0. Now, we know it's a parabola, and we know it's symmetric. So we should be able to fill in this table as long as we go the same direction. You don't have to do all that work. So -5, you're at -3. -6, you're at 0. And those are your two graphs, since you already solved it by completing the square. It's not like in right there. So your zeros are where it crosses the x-axis. That's what you're supposed to find. And that's your answer. Okay, when we look at a table as long as the x's go up by the same amount each time, 5, 6, 7, 8, 9. Remember, if the first differences are the same, it's linear. So from 2 to 8, we're going up by 6, aren't we? From 8 to 32, 32 minus 8 is 24. It's not linear, is it? Because they're not the same. And let's take 128 minus 32. That gives me 96. If I take 512 minus 128, so that gives me 384. I did that not because I was thinking it was linear, but if the second differences are the same, then it's quadratic. So, from 6 to 24, you're going up by 18. Are you going up by 18 from 24 to 96? No, that's not 18. So it's not quadratic. Now, if it's exponential, we're multiplying or dividing the same thing. So I'm going to erase everything here that I did. And I'm going to say, hey, if it's exponential, we're going to multiply or divide to find the next term. Well, if I look from 2 to 8, I'm multiplying by 4, aren't I? From 8 to 32, look at that, we're multiplying by 4. 32 to 128, we're multiplying by 4, aren't we? Because 2 times 4 is 8, and 4 times 3 is 12. If you take 128 times 4, or if I take, let's take 128 times 4, I get 512. So that's multiplying by 4, isn't it? Since I'm multiplying by 4, that's exponential. If it wasn't the first difference, or the second differences, or if you didn't multiply or divide, then the answer would be none. Okay, we're going to graph this parabola. And you didn't do this one. Plot 5 points on the graph. 2 points, find the vertex, 2 points to the left. Okay, now the nice thing when it's in vertex form, we know the vertex. Because it's x minus h plus k. So our vertex, h, remember it's always x minus, so let me blow this up and rewrite this for us. So this is actually x minus negative 3 squared plus 2. So our vertex is at negative 3 and 2. So now we're going to make our table, x and y. I'm going to put negative 3, 2 in the middle of my table. I'll do a couple numbers to the left and a couple numbers to the right. So I'll go negative 4, negative 5, negative 2, negative 1. We should know by now that this parabola is going to be symmetric. So you don't have to do all 5 points. You do have to do some other points, but just make sure it's symmetric. So now, let's put in negative 2 for x. I'm going to write down the problem here so I can look at it. So x plus 3, the quantity squared, plus 2. That's what we're graphing. I want to make sure there wasn't a number in front I didn't see. So we'll put in negative 2. So negative 2 plus 3, the quantity squared, plus 2. Negative 3 plus 2 is 1. Squared plus 2, so that's 1 plus 2, which is 3. I think I'll graph those 2 points before I forget. And we also know negative 4 is going to be 3 because we know it's symmetric. So I have negative 3 and 2. I have -2 and 3. And I know it's symmetric, so -4 is also at 3. Now let's do -1. So we have -1 plus 3, the quantity squared, plus 2. -1 plus 3, well, that's 2 squared plus 2. That's 4 plus 2, which is 6. So we know it's symmetric. So I know -1 I'm at 6, and -5 I'm at 6. So -1 I go up to 6, and -5 I go up to 6. And on Alex, you can just click on the curve, but I'm going to draw it by hand here. It should be going through the... So we know it's U-shaped, and it goes through your vertex. Okay, we want to solve this for you. No, do not move that 6 to the other side unless you're going to complete the square. I don't know why you divided by 2. You could do this by completing the square, but you didn't use that to complete the square. Always try factoring, because factoring is so much shorter, and you end up with nice numbers. That is, can I find two numbers that multiply to 6 and add to -5? Well, yeah, -3 and -2. That's from last chapter. So we get u minus 3 times u minus 2 equals 0. So you separate them. U minus 3 equals 0, or u minus 2 equals 0. We add 3 to both sides, u equals 3. Or you add 2 to both sides, u equals 2. And since they want you to type it in with a comma, on Alex, you're going to go u equals 3, 2, or 2, 3. It doesn't matter. Okay, a word problem here. And the one thing I want you to notice, and I think that's where we made the mistake, is you rounded. Don't round. So if we take a look, it says a medical equipment company manufactures x-ray machines. The unit cost C to make every x-ray machine depends on the number of machines made. If X machines are made, the unit cost is given by this function. What's the minimum unit cost? Notice it's a function. It's going to be a quadratic. It's going to be a parabola. So the minimum is going to be at the bottom of your parabola. The minimum is going to be your vertex. So now let's do x equals -b over 2a. So that would be the opposite of -504 divided by 2 times 1.2. Well, that would be positive 504 divided by 2.4. Well, I think we'll use our calculator here. 504 divided by 2.4. So 210 is the magic number of machines would be your minimum cost. If you make more or less than 210, then you're going to have an increased cost. But that's not what's asking. It's not asking for how many machines are being made. It's asking for the cost. Well, the cost is C. So C equals, in other words, I'm going to find C of 210. So I'm going to say C of 210 equals 1.2 times 210 squared minus 504 times 210 plus, kind of run out of room here, plus we get 71,791. I'm going to tap that in my calculator because the calculator will do everything for this problem. 1.2 times 210 squared. So 1.2 times 210 squared. And then we said what comes next? Minus 504 times 210. Minus 504 times 210. And then there was a kind of a big number on the end. What's in there? Plus 71,791. 71,791. So in other words, the cost for each machine, the cost to make those machines, the minimum cost, is $18,871. They're not cheap. So that's what it costs the manufacturer to make if they make 210 machines. So I'm guessing they probably sell them for $50,000 each, or maybe even more than that. Okay, this one. You got the first part right. A is correct. For B, I want you to choose the coefficient that's closest to 0. Closest to 0 is the widest parabola. Because we know A, as it gets really close to 0, gets really, really wide. Which one of these is the widest? Well, it's not C that you chose. It's A. Choose the coefficient with the greatest value. Well, the greatest value, since it's greatest, that's going to be the skinniest opening up. Because it could have a big value opening down, but that would be a large negative. So I look at I only have to choose between A and C. Which one of those is thinner? Well, that would be C. And you had A. You had the exact opposite. You got those two mixed up, it looks like. Okay, graph the parabola. I'm not going to go through this one because we've done, I'm going to go over this one because that 2 makes a difference. So my vertex, because it's in vertex form, is at 6 and 4. So when I make my table for X and Y, I'm going to put 6 right dab in the middle. And I'll go 7 and 8 and 5 and 4. So let's find our first point. Let's find when X is 7. So I have 2 times 7 minus 6, the quantity squared, plus 4. Well, I take 2. 7 minus 6 is 1. 1 squared is 1. 2 times 1 is 2. Plus 4 gives me 6. So I know when X is 7, Y is 6. When X is 5, Y is 6. Now we'll take a look at what happens when X is 8. So I have 2 times 8 minus 6, the quantity squared, plus 4. So 2 times 2 squared plus 4. 2 squared is 4 plus 4. 2 times 4 is 8 plus 4 gives me 12. Since I know my graph is symmetric, I know both these points are at 12. Now let's plot our points. I'm going to start at 6 and 4. And then I'm going to do 7 and 6. Which is also 5 and 6, isn't it? Since it's symmetric. Then I'll do 8 and 12, which would be the same thing as 4 and 12. I messed up here. Over 6 and up 4. 5 and 6. No, I didn't. I just can't see right now. There we go. And then there's our parabola, which is a lot easier for you to click on. And that's the review of the MT9 affirmation that you have to redo.